Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel Haikal bin Azlan. So right now, I'm gonna present prelude of distillation column. First, background theory of the experiment. The distillation column is a vertical tower containing a series of plates used to separate a mixture into two or more products that have different boiling points. The plates will lead to a better separation as it allows for an increase in the vapor-liquid interface. The vapor mixture will rise from the boiler to the top passes of the column trays as the liquid runs down to the bottom. The vapor then enriched in more volatile component, which means low boiling point, and liquid is enriched with less volatile components, which mean high boiling point. Besides that, the rises vapor mixture attempting to achieve equilibrium at each tray with the liquid condensate, hence effecting both mass and heat transfer to obtain completed exchange. Second, objectives of the experiment is to determine the high equivalent theoretical place or HETP at total reflux. Also, to determine the effect of liquid and vapor loading on the HETP at total reflux. So this is PFD, short term for process flow diagram. So this is PFD for distillation column. Since this is the first time I will do this experiment, so this PFD will help us to locate the location of all the valve, reboiler, condenser, and so on. So before we start the experiment, we have to follow the general startup procedures. And after finish the general startup procedures, then we can proceed to the experiment procedures. So first we have to ensure the reflux control is zero position, total reflux at control panel. In the PC, set in the manual mode, then set heater power control to 50%. Ensure the set point of reboiler temperature is 85 degrees Celsius and set point value also in 85 degrees Celsius. As the top column temperature sensor and bottom sensor reach steady state, record the temperature at the tray's top and bottom column. Collect the sample product at top and bottom. Make sure all the remaining liquid in the sampling valve are removed. After that, record the refractive index Ri of the product samples into data table. Switch off the heater, wait for approximately 10 to 20 minutes and allow the distillation unit to achieve new steady state. Drain all mixture in the top and bottom tank. Repeat for different liquid and vapor loading by adjusting the heater power, manipulated variable to 75% and repeat the procedures. After finish the experiment, we have to proceed with the general shutdown procedures. Next, how to collect the data or result. We have to collect the top product by place the beaker below valve 11, set the reflux divider to position 1, total distillate, then open valve 11 to collect the enough sample top product. Close back the valve 11, then set reflux divider back to original setting, position 0 equal to total reflux. Next, to collect bottom product sample, partially open valve valve 32 to allow product sample flow through bottom cooler. Then close back the valve 32. Place the beaker below valve 9. Then open valve 9 to collect enough sample bottom product. Then close valve 9. Then obtain their refractive index readings using a refractometer. Missing data. Missing data are the data that not available from the experiment. So how to obtain the data? We need to do a calculation. So these are missing data. For example, mole fraction can obtain from composition analysis of ethanol in concentrated samples. Next, theoretical number of plates can be obtained from McCabe-Thiele method, which is graph. Next is height equivalent theoretical plates, HETP. We can obtain from the formula effective column height divided with the number of theoretical plates. So this is the formula we will use to calculate the missing data. First, formula of composition analysis of ethanol in concentrated samples. Second, formula of height equivalent theoretical plates. Then the third one is McCabe-Thiele method. So this is the example. So this is the example of graph that had been constructed using McCabe-Thiele method for total reflux. So there will no EOL, QOL, and SOL line in the graph. The last one is expected result. So the first one is height of equivalent theoretical plates at total reflux remain constant even the heating power change. Second, the liquid and vapor loading on the high equivalent theoretical will be constant at certain point. That's all from me. Thank you.